Hey Pre-16 students, here's a video covering the last page of the notes from Class E, as well as a couple more things I wanted to mention. So the first one is to solve for x, we're going to log base x of 100 equal to 2. Really, this is just an exercise in rewriting this as an exponential equation. So your base here is x, the power is 2, and it's equal to 100. So the solution to this equation, actually the solutions to this equation would normally be x equal to 10 and x equal to negative 10. However, when we have logarithms, the bases are not allowed to be negative numbers. So the only answer here that's correct is x equal to 10. So the same thing over here. We have log base x of 27 equals 3 halves. So we're going to rewrite that as x to the 3 halves power equals 27. Our base is x, power is 3 halves, it's equal to 27. And then the way to solve this, so we didn't actually show the work here, but the way you could have solved this was by taking the square root of both sides and saying, oh yeah, the square root of x squared is plus or minus the square root of 100, get x equal to plus or minus 10, but then we cross out the negative 10. So to undo a square, you do a square root or a 1/2 power. To undo a 3 halves power, you're going to raise both sides to the 2/3. So x to the 3 halves to the 2/3, we can multiply those powers. And 27 to the 3 halves, I'm going to write that as 27 to the 1/3 to the second. 3 halves times 2/3 is 1. So this is x to the 1, which is just x. And 27 to the 1/3, or the cube root of 27, is 3, because 3 times 3 times 3 is 27. So x to the first equals 3 squared, or x equals 9. So that's the solution here. Log base 9 of 27 is equal to 3 halves. Okay, a couple other things. Log base 3 of 3 to the 4th. This says 3 to the what equals 3 to the 4th. Well, of course, the what has to be 4. So log base 3 of 3 to the 4th is equal to 4. Same deal here. Log base 5 of 5 to the 80th has to be 80. Because this, again, this says 5 raised to what power equals what's right there, which is 5 to the 80th. So it has to be 5 to the 80th power equals 5 to the 80th power. Pretty straightforward. Over here, same kind of thing. 2 to the log base 2 of 8. Well, this one we can actually calculate. Log base 2 of 8 is 3, right? Because 2 to the 3rd equals 8. Then 2 to the 3rd equals 8. The point here is that if the base here and the base here are the same, you end up getting this as your answer. So again, I'll remind you, the log base 2 of 8 is the number that we raise to get 8. It's a lot of 2's, right? The number we raise to get 8. Okay. But then we're raising 2 to that number. So we're raising 2 to the number that if you raise 2 to that number, you get 8. So we get 8. Same deal down here. 3 to the log base 3 of 7 is going to be 7 because this here is the exponent that if you raise 3 to that exponent, you get 7. So we get 7. If you don't like saying that, which is fine, you can also do this. You can say, well, I'm going to say this is equal to x. And then I'm going to write this exponential equation, 3 to the thing equal to x, as a logarithmic equation. So I want to write this as a logarithmic equation. I can say, I'm going to call this y for a second. So 3 to the y equals x. And rewriting this as a log, it's log base 3 of x equals y. Right? Because y is the exponent. So y is the thing the logarithm is equal to. But y is log base 3 of 7. So log base 3 of x equals log base 3 of 7. So x has to equal 7. Which means this 3 to the log base 3 of 7 is equal to 7. People like to say that the 3 to the log base 3 kind of cancel out. I would rather you think of them as undoing each other. 3 to the something and log base 3 of something undo what the other one does, so you're left with just what you started with 7. All right, that's all I have to say. I hope this is helpful.